right, so now we're going to look at question 9 of the physical properties worksheet. And what we have here is we have the boiling points of straight chain alkanes and straight chain alcohols, and they are compared to each other. Okay, so here we're going to be comparing functional group because we have alkanes and alcohols, and we can compare straight the number of carbons in the longest chain. So there's lots of explanations in this question, guys. So what I'm going to ask you to do is the memo was given to you when we did this. So I'm going to talk through it. I'm just not going to write it all out. Otherwise, we're going to be here till Christmas and you're all going to fall asleep. So explain the increase in boiling points of the alkanes as indicated. So in basic terms, all right, we're going to do this here. The alkanes, what's happening? The chain length is increasing, all right? So the chain length gets bigger. If the chain length gets bigger, then the intermolecular forces increase, which then means the amount of energy we need to overcome those forces also increases. Straightforward. 9.2. Explain the difference between the boiling points of the alkane and the alcohol, each having 3 carbons, by referring to the type of intermolecular forces. So now I'm looking here. The alcohol has a significantly higher boiling point. It's 98 degrees, whereas the alkane is only minus 42. Why? They won't refer to the type of intermolecular forces. Alkanes have London forces, have very weak London forces. All right? The alcohol has strong hydrogen bonds. Okay? Hydrogen bonds are stronger, therefore more energy is needed to overcome the intermolecular forces, so their boiling point increases. Next question. Does the vapor pressure of the alcohols increase or decrease with an increase in the number of carbon atoms? Well, as we go down, the boiling point increases. Boiling point and vapor pressure are the inverse of each other. So if boiling point increases, vapor pressure decreases. Then they ask you, how will the boiling point of 2-methylpropane compared to that of its chain isomer? Okay, so this is very similar to question 8. And then they say to you, write down higher than, lower than, equal to, and give a reason. Now, first of all, the only chain, when we draw out 2-methylpropane, okay, 2-methylpropane is this. In other words, the chain isomer is butane. It's a straight chain. Straight chains have higher boiling points than branches. Okay, so that means it's lower than. Why? Because 2-methylpropane is a branch chain. Okay, more branches. When it has more branches, smaller surface area. All right. Ooh, no, I didn't want that one. There we go. Smaller surface area means weaker London forces, intermolecular forces. All right. Don't think you can actually read that, but we'll go with it. All right. Weaker London forces, therefore less energy needed. Okay. But they wanted you to refer to the structural difference, so you have to talk about the branches. Okay? Straightforward. When it comes to physical properties, it's the same type of question over and over and over again.